right, since I'm not here today and there's going to be some parts that need to have a demonstration, I'm going to try to do this with a video. So some parts I'll walk you through and some parts you'll need to answer on your own. The first thing is, our topic today is to comparing the Bohr model to the earlier Rutherford or Chadwick model of the atom. So go ahead and answer that first question. Looking at these two pictures, what's the main difference between the Rutherford-Chadwick model and the Bohr model? Now, what we're going to be doing next is we're going to be looking at the atomic emission spectra. And you can see that it says the atomic emission spectra of an atom is a specific pattern of colored lines that is seen when light is emitted from a sample of identical superheated atoms that are viewed through a prism. So you're going to look at the handout entitled Atomic Emission Spectra. And I will show you that in just a second. And we're going to be looking at the pattern of colored lines. And the bottom section, which you can see here, is what you're going to be using to determine which mixture it is the mixture of gases. So let me pause this and pull up the atomic emission spectra. So we're going to zoom in on the atomic emission spectra, which is on my next two gases, is going to be sodium and manganese. So now I'm going to turn to the next one and leave the atomic emission spectra up there so that you can do mixture of B, C, and D. Page. Here it is. So we've got unknown A, B, C, and D. So let's take a look at unknown A. So you can see my atomic emission spectras. I've got colored lines. So here I've got a line that's purple for hydrogen, a line that's blue, I've got a green, I've got a red. For strontium, I've got a medium blue, and I've got some lighter blues. And then strontium also has an orange and it has a red. Copper just has 3 yellow. Titanium has a blue, a green, a yellow, an orange, and a red. Manganese has a purple, medium blue, light blue, green. And sodium has 2 bands, which are both yellow. So when we're looking at our unknown A, I'm going to first zoom in on this part here. I've got 2 bands. The only one that matches that is going to be sodium, so Na. Now I'm going to look at the other ones. Notice that I've got a purple, a medium blue, a light blue, and a dark blue. So the other gas that's in here, I don't have any red. So the other gas that's in here, the only one that fits is this one, and this would be manganese. So jumping back over to our other sheet here. So go ahead and pause the video and determine what are the unknown gases that are present here. I'm going to go ahead and erase this so I can just get rid of all my messiness here. So again, you're going to determine what are the gases that are mixed in B, C, and D. Go ahead, pause the video and answer those questions. So there's hydrogen. There's our 4 colored lines. What do you think is causing those 4 colors to show up using what we just did? Pause the video and go ahead and answer that question. All right, the next one's going to be a little bit difficult to understand because normally I do this as a demonstration where I'm standing there and I'm actually throwing either colored balls or I'm throwing markers or something. So it says, your teacher has drawn energy levels of the atom on the floor. 4 of your classmates will take turns pretending to be hydrogen's single electron. They've each been provided with secret instructions. Each of your 4 classmates will show a different way that hydrogen's 1 electron can move between energy levels and what happens when it does. So I want you just to record what I'm doing on these, and we'll get your notes filled in, and hopefully you'll understand by the end of this how light actually works. So we're going to look at hydrogen atom number 1. It's starting in energy level 1. Now, if I throw, let me just pause this for a second. All right, so we have an electron that's in energy level 1. It absorbs energy, and when it does, it's going to jump to, I'm going to actually make my pencil line a little bit smaller here if I can. There we go. So it's going to jump to level 3. 1, it's at 1, 2, 3. So there's our first jump. It jumps to level 3, and then it's going to fall back to level 2. And when it falls back, it's going to release red light. So whatever I'm looking at is going to have a red light that's released. Now, my next electron, I'm going to do the hydrogen atom number 2. It again is starting in energy level number 1, but this time when it absorbs energy, it's actually going to jump out to level 4. So it's jumping out to level 4, and then it's going to fall back again to level 2. And when this one, so it jumps to level 4, falls back to level 2. Now you can see that it's falling back a larger amount. And when it does, it's going to give off a green color. So the difference between red and green is that green is more energy is being given off. Let's take a look at hydrogen atom number 3. It's going to start in level 1 again. And when that little electron absorbs energy, this time it's going to jump all the way out to energy level number 5. Again, it's going to fall back to 2, and it's falling back more energy levels. So again, it's jumping to 5 and falling back to 2. And this time when it releases energy, it's going to be released in the color blue. Now our last atom, it's the hydrogen atom, and it's starting in the electron starting in level 1. It's going to jump energy, it's going to absorb energy, go all the way out to level 6, fall back again to level 2, and this time, when it falls back, it's going to release the color purple. Now I don't have a purple pen, and I guess this won't really let me, so I'm doing red and blue together to make it kind of look a little bit purpley. It's going to give off purple. So when we're looking at different colors that are given off, if we're looking at the amount of energy, red has low energy. It gives off a low energy wavelength, and then it gets more and more energy that's given off until purple would be a high energy. And green and blue would be in the middle. So it says, compare the colors emitted by each of the electrons in the atomic emission spectra for hydrogen. What do you think is the origin of the 4 colored lines in the atomic emission spectra of hydrogen? So we're going to go ahead and I'm going to back up so you can see that. And you're going to answer the questions, what do you think are the origin of the 4 colored lines in hydrogen? All right, the next one says, in order to understand Bohr's model, we need to learn a little bit about the nature of light and color. You're going to open up the envelope labeled Color of Light's card set, and these are located in the front of the room. The card set contains cards that illustrate the energy, wavelength, frequency, and the speed of light of different colors of light. The symbols that are used for wavelength, frequency, energy, and speed of light are indicated in parentheses. Now you're going to follow these directions. You'll locate the red card, and then write down, just answer the questions based on these cards. All right, and then you go ahead and do this one. You go ahead and do that. This is all using those cards. All right, and then you've got your formula for calculations. So go ahead and pause this video and use those cards to answer the questions we just skipped past. Then we'll start part 3. Part 3 says the relationship between wavelength, frequency, and the speed of light is illustrated in the following formula. So we've got C. C is the speed of light, equals F, which is frequency, times the wavelength. And that has that weird symbol there. So in the formula in words is speed of light equals the frequency times wavelength. You've got an example here of how to solve the problem. This is just isolating your variable like we've done before. So you're going to go ahead and you're going to rearrange the formula and do the problems. All the way to there. And then you're ready to do the Excite game board. We're going to do this because it's actually where you're going to get your grade. So you're going to ask your teacher for the game board. They're actually, I believe, the last page in your packet. She'll give you a pair of dice and a set of game cards. Now, the game card answer sheet is also located in your packet. She'll also give you a little chip so that you can use that as a game piece. So you're going to be practicing calculating the wavelength, frequency, and energy by playing the game Excite. So the first thing you're going to do is separate the game cards into stacks of light cards and energy cards. The first player is going to roll the dice and advance their game piece to the indicated number of spaces. If the player lands on a light space, you're going to draw a light card. If you land on an energy space, you're going to draw an energy card. You'll then calculate the answer to the card and record the answer on your game card answer sheet. Other players should also calculate the answer at the same time. The other players must agree that the current player's answer is correct. If the answer is incorrect, the player loses a turn. Disputes will be settled by the teacher. If a player lands on a space at the bottom of a ladder, he or she must climb back to the space at the top of the ladder. If a player lands on a space at the top of a chute, he or she should slide down the chute to the space at the bottom of the chute. The player that gets to the last space on the game board first is the winner. Again, these cards are going to be located in the front of the room.